Saxon Algebra 1, Lesson 22. It's a two-parter, guys. The first part, we're going to practice putting words into symbols. One of the biggest challenges of doing any kind of word problem is figuring out how to take words and convert it into an equation that you can solve. So we're going to practice. We're going to begin practicing that a little bit today. We don't have a formal example problem to work, but John gives us some, let me show you. I don't want to write it all down. He shows us these 4 sentences here. I'll read them to you because you probably can't see them very well. But what we're going to do is just take this much and practice putting it into words. The number of peaches equals the number of apples. The number of peaches does not equal the number of apples. The number of peaches is greater than the number of apples. The number of peaches is less than the number of apples. Okay, blah, 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 blah. Those sound a lot the same. But the most important thing we're going to do is we're going to set up our variables to look like this. Do you see this little letter here? This is called a subscript. This whole thing is called a subscripted variable, which means that it's a little symbol we can use that will stand for the number of peaches. And the reason John uses this is because the letters help us remember the words. It helps connect the two together. When I was learning algebra, my teacher would always just say, oh, let's let x equal the number of peaches. That's random, and it makes the problem harder. If you can make the letters match to what they represent, you're so much better off. And there's the number of apples. Now, if we say, as John does, the number of peaches equals the number of apples, number of peaches equals the number of apples. The words and the symbols go together really nicely. What if we want to say the number of peaches does not equal the number of apples? We have a symbol to say that, don't we? We've got the variables and we have a symbol for that one too. Equals does not equal. Okay, what about the number of peaches is greater than the number of apples? Aha, got that one covered. And the last one, the number of peaches is less than the number of apples. So we're beginning this process of learning how to take words and turn them into symbols so that we can create equations. And John wants to put this in your head, even though we're not doing any problems yet, because I mean, this is really easy. That's hardly a problem, but we're gonna build on this. So start wrapping your head around it and we'll go on from there. All right, the meat of this lesson, blump, is a type of problem called conditional equations. And I like these because they're kind of like detective work. And there are 2 of them that we're going to work, and then we're done. 22.1. Does -2 or +5 satisfy the equation x squared equals -5x minus 6? And that got a little messy. So what John's saying is, try both of these values in this equation, plug them in, and see if it comes true, because it says that they should be equal. But let's see if they come true. Okay, so what we'll do is first we'll test -2. So we have to write this with parentheses, or as I like to say, buckets. And remember that when we do this, we copy the equation exactly the same. It's just everywhere we see that value that we're going to plug in, we put a bucket just around the letter itself. The numbers, the minus signs, the exponents, all stays the same. It's very important that you learn to do this precisely because we're going to be doing it for a long time. Now I can plug in -2. Notice that the minus sign goes into the bucket with the 2 because they are a package deal. Now we're ready to use some order of operations business to simplify this. So remember, order of operations, we do any work inside parentheses first. Then we do exponents and roots. Then we multiply or divide, and then we add or subtract. So there's our order of operations. We're going to want to keep that straight. Okay, so parentheses, these parentheses are just for the exponent, so we'll get to those next. And these parentheses are just to show multiplication. So we'll get to that. So we don't have any work to do inside of those. So now let's go and fix our exponent. This is minus 2 being squared, so that means the minus sign goes along for the ride. We're doing that, right? So this becomes positive 4. Okay, that takes care of the exponents. Now I'll go ahead and do multiplication because I don't have any here. It's what comes up here. So that will be positive 10 minus 6, and then that's our last step, is to do that subtraction. And what we get is 4 equals 4. So it looks like positive 2 works, right? That's true. 4 does equal 4. So we would say, yes, that's part of our solution. Makes sense, right? Let's try the positive 5. We're going to do the very same thing. We're still using this equation, and we're going to create the buckets and set it up to test this other number. Okay, that's exactly the same. Now we're plugging in 5. I'm not going to put the plus sign. That just will confuse me. And we use the same order of operations to work it through. So we know the parentheses are just multiplication. We do this. We get 25 equals minus 25 minus 6. And that goes to 25 equals minus 31. Whoa. I hear the needle skipping across the turntable again, don't you? Or maybe it's the sound of a train skidding off the tracks and falling over the bridge and into the icy river below. But this does not work. So that means that's no bueno, and this is the way I would show the answer. I would show both numbers, and I would show a box around one and a slashy across the other. All right? John writes it out, minus 2 is a solution and 5 is not. Okay, second and last problem for this one is minus 2 or positive 5, a root of the equation. And now there's a different equation. This time it is x squared minus 3x equals 10. All right, so it's the same process. We're taking these two values and we're testing them to see if this will come true. Okay, so we have, we set up our buckets. We're going to try minus 2 first. All right, and then we simplify. Again, we use our order of operations. I can see that my parentheses don't have any work to do inside of them. So I do my exponent next. That's positive 4, because just like here, the minus 2 is inside. We can't get at it to cover it up. So that means the minus 2 is multiplied out. That's positive 4. Then here's another multiplication. That will be plus 6 equals 10. Okay, that sounds pretty good. 10 equals 10, right? I can write that out as one last step. So this is true, and so this one is a good choice. All right, now let's try the positive 5. Maybe we'll have better luck with this, maybe we won't. I set this up with buckets again. And we get 5 squared minus 3 times 5 equals 10. Let's simplify. Exponents first, that's 25 minus 15 equals 10. Oh, look, that one worked too. 10 equals 10. So this time, both of the numbers given satisfy the conditional equation. So they're both right. I'll do it like this. Okay. John uses two sets of words to describe this. Here he said, does minus 2 or plus 5 satisfy the equation? But here he said it differently. It was the same problem, but he said, is minus 2 or plus 5 a root of the equation? This equation is a special kind of equation called a trinomial equation, and we're going to be doing a lot with them later on. And a root is just a fancy name for the answer of a quadratic equation, a trinomial like this. It's a trinomial and it's called the quadratic equation. It's both of those things. It's so fancy, you guys, that we call its answer, sometimes we say roots. It's just x equals, okay? So when you see that root, just know that it means answer. That is lesson 22. It's kind of fun. Just use those little buckets and you will not go wrong. Thank you. Goodbye.